Okay, so welcome back after the break. People will be joining in the next 2, 3, 4 minutes. I guess that's absolutely fine. Let me start talking about Azure virtual networking. So the first things first, the reason why we talk about Azure networking, or why do we even need a network, a networking segmentation in Azure? The reason is isolation and segmentation. So Azure Virtual Networks enable you to isolate your resources. Now, let me tell you why. What's the advantage and why are we doing it? So in certain scenarios, when you have, let's say, a group of resources, you want a database to only communicate with the application that has the authority to do that. Or, if I go back to draw.io, let me explain this concept with a diagram. Maybe let's say in our use case, we have a virtual machine. This virtual machine is running, you know, some code on Python. It's a website that is hosted. Someone from ECSGA, please admit the people. Thank you. Along with this, we have, let's say, a database, which is nothing but, let's say, MySQL. Now, when we want, and in a real world example, you might have more than one VMs. Something might be running PHP, something might be running, just general purpose VM. Something might be a Python based website. Something might be Node.js. In one specific case, if you want, maybe just one virtual machine to be able to access the database, not the other virtual machines within your own network. And I'm not talking about different accounts, I'm just talking about your account. So let's say if you have multiple VMs in your organization and you only want one, two, or three of them to be able to access that specific resource, you could be having you can be creating isolation between them by adding them into a security into a network. You can be creating a subnet and you could be applying policies. So for example, let's say if we create a subnet in which we add these three machines, we can create policies in such a way that only three machines will be able to communicate with each other. So this is basically isolation and segmentation. So we have segmented we've segmented our resources. So this is one. Let me take another one. Okay. So let's say this is one of the networks. That's another one. Let's say this is our first virtual network one. This is virtual network two. You could practically have as many virtual networks as you want, but just giving you an idea. Okay. And then with a virtual network, you might be following different IP series. Like if you guys are aware about private IP addresses, so we might be using, 10.0.0.1/256 and 1/16 and 1, and then another one might be using 192.168, something of that sort. Again, these are not values to be kept in mind, but just telling you there could be a machine that is not a part of these two groups, that is just isolated within a group of itself. So that is again one possibility. We'll just say this is virtual network 3, and then this is all under the same Azure account. So let's say this is my this is my Azure account. I'm the owner of this account, and maybe even in the same subscription, I can do some segmentation. Now, segmentation is when I have multiple resources, such as virtual machines, such as databases. Let me add another, storage service. Let's say if this is the blob storage, for example. So these are all different storage, these are all different instances. What we could be doing is we can be using virtual networks so that we can have rules on what can access what, right? So basically, if we want this database, if we want all these machines to access each other, maybe let's say the purpose of having this virtual network one is for, the HR management system. Okay, so if let's say if we are running HR management system, we'll put all the resources within this group. Let's say for a virtual network too, this is for the company's website. So we'll call it, let's say main website. Let's say we are starting development of a new website, like, a website 2.0, which is still not in production. So it's a test resource. So we'll say that, okay, this is for the, let's say new website. So you can have different resources. You could be putting them in different virtual networks. When you put them in different virtual networks, you are performing something called as isolation. Okay. So a lot of people coming in. Let me go back to this. So Azure Virtual Network enables the creation of isolated networks with private IP addresses ranges that aren't internet routable. So IP addresses space can be divided into subnets, and the virtual network can use Azure's built-in name resolution service, or it's like an internal DNS for name resolution. Now, for those of you who are totally new to the concepts, do not get overwhelmed. Let me walk you through this diagram. After reading definition, it's going to make things easily understandable. So let's say if we have one Azure account, and within one company you are working on multiple projects, right? You are working on your HR management system, which is handling the payroll, the employee engagement, and the employees coming in and all that stuff. Your leave tracking, your hours, your time sheets, all that stuff is a part of HR management system. To run that, you're using an API that is running on Python, some middleware that you're running on PHP, and some blob storage that is storing some files, a combination of all of them. So what you can do is you can put all these resources within one network. When you put them in one network, you're giving them, because all these resources will definitely have internet accessible, public IP addresses. But at the same time, you're giving it a series of numbers. For example, we'll say that this subnet is going to have, and this is again not real values, just giving you an example. For example, 100.0.0.1, all the way from 100.0.0.1 to 100.0.0.255. Let's say if we give this range, now these machines will be having IP addresses in this range, and only they can communicate with each other. They cannot communicate with other devices or other appliances, or let's say other resources and different machines that you have. So basically, this is nothing but this is segmentation and isolation. So you are having segments. So this is one segment which is for HR. This is the second segment that is for your main website that you're working on. Then you have a third segment which is for your new website. So there's just one resource tagged to that. And then when you add them in, when you add your resources in the network, all the other resources within that same network are able to access the that specific resource that you're talking about. Does that make sense to all of you? The reason why we do networking, we are we are virtually isolating resources so that this VM cannot communicate with this VM. Or for example, if this VM cannot communicate with this VM, that's why, in fact, a better idea would be if I give these machines numbers so that you get better understanding. So let's say I can have virtual machine 1 over here. I can have database 1 over here. I'll copy this, I'll put this with this resource as well, so that, we'll put database 2. Let's say we do some analytics and we realize that SQL server is better suited for our case. We might just enter, we might create an SQL server instance instead of MySQL. So depending upon your requirements, you can be having different resources. Now, from a security standpoint of view, you do not want this database to be accessible by any other resource or from the internet. So you could disable internet access, and you could be, provisioning your virtual network in such a way that only the devices or only the resources within this subnet or this virtual net can access your resources. So it's like, having a layer of isolation in between. Does that make sense to all of you? Give me a thumbs up if it does. Okay. So that's kind of great. You guys are catching up, and I'll share this draw.io with you. So these are nothing but just class notes. So you get the idea. So this is what is virtual networks that we use. Uh, so when we were talking about, let's go back to my slide, it was Azure virtual networking. The reason we practice Azure virtual networking is it is used for isolation. That is so that one device cannot be communicating to the other if it is not supposed to. And segmentation, that is you knowing where your resources are located. For example, if someone asks you that, HRMS, we are stopping using the HRMS. From tomorrow, we'll start using something new like ADP or maybe SAP or some other HRMS that comes in play, you can take down all the resources at once and move your data to the new service. So that is segmentation. You're classifying them, you're grouping them more of like a resource group, but at a network level. And in addition to that, you are also isolating them so that you can set roles on what can access what. Uh, okay, so you have a question. According to the graph, where does the Azure subscription take part? So you can see that in the video. We've already discussed about that in the morning. If you still have your doubts unanswered, let's take that up next week in the doubt session. And for the second question that you have, will this segmentation allow me to know how much I will be billed? No. If you want to have segmentation on the billing level, that is subscription. If you want to have segmentation on the network level, where you are deciding on what appliance or what resource can communicate to the other resource, like I gave the example, what database can connect with which, let's say, what database can connect with which virtual machine. That is something that you are looking when you are talking about network isolation and segmentation. I hope that answers your question in the chat.
Yes, thank you.
Awesome. Let's go to internet communications. So to enable incoming connections from the internet, you can assign a public IP address to an Azure resource or put it behind a public load balancer. Now, this is very, very important. Let me go back to draw.io, and it's going to be, very easy to understand when we look at the diagram. So you guys can see that we have quite a few resources with, uh, within three different virtual networks: virtual network 1, virtual network 2, virtual network 3. Let me add more details. Let me first remove a few things. Let me just delete this. I'll tell you why am I doing it. This is just for an example standpoint of view. You'll understand that in a bit. Okay. So this is virtual machine 1. This is virtual machine 2. And let's say this is the Python API. Let's say this is the PHP front end and middleware. Okay, that's information about our network. Let's say we have a database, and then we have blob storage, which has some pictures. Okay, so I'm just giving you an example of a website. So this is the kind of data that we have. Now, we also have a new website, obviously. So let me put this on the side for an example. Now, in this use case in Azure, we want that, no one should be able to access everything from the internet. No one should be able to access the API. They should only be able to access the front end, and then the front end is making a, maybe some call using the middleware to the API. We want this to be secure so that no one outside the network can access it. So what we will say is, for this specific virtual machine in the Python API, we will say it has no public IP. That means it cannot be connected to the internet. It can only and only be accessed from within the network. The second machine will say, in this second virtual machine, we'll say that public IP. For example, let's say the public IP is 10.23.43.21. And again, this is just a random number. Do not quote me on the numbers. I'm just giving you an example. Okay. So let's say if this is the public IP, and for other resources as well, we block the public IP. So now what is going to happen is we need to write our code in such a way that only this machine can communicate with this machine. This machine can communicate, let's say, with the database. and only this machine maybe could manage the blob as well. So if it has to read some file which is storing some personal information that you do not want the world to access, so you are following this policy where you are giving no public IP address to the resources which you do not want the world to access. Now, if you do not want people to access your resources over the internet, you want to secure it, you're following the practice of, security in depth. What you will do is you will design your infrastructure in such a way that if someone is accessing this, let's say if I am the user on the internet, I would only and only be able to access this virtual machine. So please understand what's happening. I'll be entering the DNS that will be converting it to the IP address. Like for example, www. ECSGA's new or ECSGA's website.com, just example. In that case, DNS will be routing me to the IP address, and then the IP address will be opened. So the connection that will go on is the user on the internet can only see this machine, whereas everything else is behind and you'll not be able to see it. Does that make sense? So it is a form of security. People might attack your database if it is public. People might attack your blob storage if it is public. People might attack your API if it is public. If you figure out a way to develop a front end and middleware in such a way that everything is only accessible by this machine, which is also called like a jump connection, no one on the internet will be able to access these resources because they will be hidden behind the virtual network. And that network will not, and if you've not given the public IP, they can communicate with each other using the private IP, but public is what is given to the world. Okay. Now I know there are many of you who are totally new to, cloud concepts. That's why it might have gone over your head. Let me explain this one more time before I start taking the doubts. Please understand this very carefully. Let's say I have a website which requires quite a few components. The first component is a database. We have one backend machine, that is the API. We have front end and we have middleware on virtual machine 2. And then we have blob storage, which is storing some data, some files, which you do not want the world to access. So if you want to design your solution in such a way that it is very secure, you will only allow internet traffic to go through the front end of the website or the middleware of the website. Everything that happens in the background will be behind this. So no one will be directly able to attack this. No one will be directly able to attack this. No one will be directly able to attack this. That is making your infra more secure. Hence, you will only be working on the security of VM2. By default, the security of VM1, blob storage, and database 1 will be managed, because it's not accessible over the internet, it has automatically become much more secure. Does this make sense to you? If it does, give me a thumbs up. If it doesn't, it's absolutely fine. It's a totally new concept. I can explain it once again. Too difficult to understand or all clear? I am just seeing 9, 10, 11 of you being active. I want the entire audience. Come on. Okay, Gautam, I'll explain with an example. If you guys do not understand, please be honest about that, because that makes things a little easy for me. So, okay, now please observe what is the scenario. Let's say you want to run a website, which is, let's not call it human resource management system. Let me be, if I'm giving an example, let me use something realistic. Let's say this is ECSGA website. Okay. And this website is using multiple resources to work. It has one file storage, which is the blob storage. Let me mention this is file storage so that no confusion. We have a database. We have a virtual machine that is running the backend, which is the Python API. And now what we have done is we have not given it public IP addresses to these three sources. That means that these resources cannot be accessed by anyone from the internet. So they are not exposed to the world. They are hiding in the background. Only the appliances, they can communicate with each other, but they cannot communicate with the internet. So for added security, what we are doing is we are putting them in the same virtual network. If we put all these resources in the same virtual network, what happens is that they can communicate with each other with private IP addressing, right? So these, let's say if this is the private IP address So when we give it a subnet, we are giving it a range. So if we have given it a range, you can see this is the range within which they can communicate. Okay. Just a minute. Let me bold the stuff that I have. Okay, so these resources have some, private IP addresses, and only this resource has a public IP address. That's why it is shown in green. So the world can only access this resource, whereas this resource can access other resources in the background. So if you practice this, you are technically making your system much more resilient to attacks. You're making it much more secure. The reason you're doing it is because you put them in the same virtual network. They can communicate with each other. This can communicate with this can communicate with this can communicate with this. But the world cannot communicate with this, and this. That gives you the advantage that you only need to focus on mainly securing your virtual machine too, because automatically the probability of attacks happening on other devices is much lower, because it is very hard to access them directly. Or let's say it's impossible to access them directly. You only need to access them via VM2. So unless your VM2 is running something wrong, your resources in the background to secure. So rather than managing and securing 4 services or 4 resources, now you just need to secure one mainly. And again, it's security, so you can never be 100% sure, but I'm just giving you an idea that the workload has reduced significantly. Rather than looking into 4 individual resource security, now you're focusing on one resource, because that resource is then connected to the other, and they are not accessed from the internet. So that means no one outside Azure can access them. If you need to access this database, you can only do this via VM2. That means that you can only do this via this subnet. Does that make sense to all of you? Gautam, I think you asked me to explain this again. Are you clear with the explanation, or you still have a doubt? Okay, Pranay, go ahead.
Yeah, my question is like, let's say if an intruder tries to enter the virtual machine too, like through the PHP front end and middleware, which is open to public, basically, as an user. So if we can manipulate that machine, can he be able to manipulate the other three which are in a private network? Like, let's say, for instance, I'm just asking.
I'll answer the question with an example. If
Yeah,
you get a lock and you lock your house, is there a possibility that no one can break it? The answer is no. Nothing can be 100% secure. But by buying a heavier lock, buying a more resilient lock, you can beat the odds of people being able to break in easily. Similarly, if you have all the resources exposed to the internet, the probability of people attempting to attack them is going to increase. But now, since you have them behind the network, obviously, if someone is able to compromise this machine, they might get access to everything, right? But at the very same time, if you are doing it right, your effort is now just to secure one machine rather than securing 4. Whereas in a real world example, this might be 10, 15, 20, or 30.
it's like making it more resilient and
Yes.
securing makes
Yes.
it to just 3 or 4,
Yes,
depending
you're
on the
trying to make it
requirement.
more, you're adding security. You cannot be 100% sure that that's a myth
Yeah,
in
yeah.
security, but it's making the process much more complicated, because now these are at least not exposed to the internet. There can be attacks happening on them, but only in the Azure network. So if someone gains access to some other resource, for example, virtual machine 2, then they can attack it. But your focus will now be only on securing VM2, because that is the only public facing machine that you have.
Okay, yeah, thanks.
Okay. Awesome. Bhargav, go ahead.
Yes, am I audible?
Yes, you are.
Uh, you are talking about the concept of subnet, right? So can you please explain what is subnet?
Okay, so subnet is when you divide a network. You divide a network within particular sections. You could be looking into the subnets. I'll just come to that as we progress, because again, drawing the entire concept of subnet on this is going to make the diagram much complicated for people to revise. But I'll just be touch basing upon that after this. Okay.
Okay, perfect.
Okay, So is everyone clear with the idea of virtual network? So if you have different virtual networks, it is basically, just name it virtual network 2, because I deleted the second one for the example sake. So now we have virtual network 1, we have virtual network 2, and obviously, let's say we have tried to follow the same architecture. So what we'll do is we'll expose this. So we'll make it in green and we'll try to protect it. So we'll put it in the background. So no one can access the database directly. They can only do it via virtual machine. Let's call this virtual machine 3. And again, the same thing implies, I'm not drawing the same thing over here, but I hope you guys can understand that from the world standpoint of view, when the world is trying to connect or anyone on the internet is trying to connect. Now, please understand, by using the concept of virtual network, we are isolating our resources. So segmentation is that now if someone has a look at it, they'll know, oh, virtual network 1 is for ECSJ website. Virtual network 2 is for a new website that we are working upon. So that is segmentation. Isolation is that this database can only be accessed via virtual machine 3 within this group. So if you want to access this database, the only way you can do it is via the public IP address that we'll give to this machine. Okay, so it's just adding more and more security. Let's say this is 100, and again, I'm just selecting some random numbers. They have no significance. And then there might be some private IP range where they'll be using to communicate among themselves. So let's say if there is a user on the internet, the user can only access this, or they could access this resource. When we talk about this specific Azure account, they'll not be able to access anything that is in orange. Does this make sense to all of you? Any questions? Don't worry, it's a very important concept. There's definitely an exam question on this. If they ask you what is a virtual network, the option will be, what is a virtual network used for? The answer to that question is virtual network is used for segmentation and isolation. Segmentation is grouping your resources together. Isolation is keeping those resources away from the other resources so that, not everything can access everything. And that is obviously done for security reasons. So this is pretty straightforward in terms of, let me, this is pretty straightforward when we talk about the networking. Let me go back to sharing my screen. So these are the two slides that we talked about. Azure virtual networking, isolation and segmentation is what we are trying to achieve. Private IP is them talking to each other, not being exposed to the internet. Public IP is the IP that enables them to connect to the internet. Internet communication, to enable incoming connections from the internet, you can assign a public IP to Azure resource or put it behind a public load balancer. So this is like, if you use a load balancer, you could have implemented it in a way. For example, let's say if you had multiple machines. Now this is a very basic architecture where you just have one front end middleware machine, one Python API machine. But if you wanted to make it fault tolerant, you might have two databases for redundancy, two blob storage instances for redundancy, two virtual machines for API, two machines for front end, and then you would have used load balancers instead of these communications. But that's not something which we are working up on right now. That's why we are not doing it. Could I have one load balancer for each virtual network? So no, it doesn't make sense to have a load balancer if you do not have redundancy. So if I put a load balancer and it only has one machine to point to, it's not giving you any benefit, right? So if you talk in terms of a large scale application, which has got multiple instances running or multiple resources running, multiple identical resources running, you might put a load balancer in front, which will decide half traffic goes here, half traffic goes here, round robin and all those things. Scheduling comes into play. Not the scope of the workshop, so I won't go into that in detail, but I hope that answers your question. And but yes, you could have a load balancer for each network. That's absolutely fine, but you need to be sure that you have multiple resources in order to have a load balancer at the first place. It doesn't make sense, like if I say I am the load balancer and I'm only managing one resource, I do not have any other resource to go to. The job of load balancer is to divide the traffic. But if I only have one machine where the traffic is going, even if I put a load balancer in front, it is always going to point towards the very same machine. Does that make sense to all of you? Give me a thumbs up if it does. 87 of you here. I expect at least 50 of you to be active minimum. Okay, not bad. I see almost all of you are active. That's kind of nice. Great. Let me go back to the presentation. Internet communication, we already talked about that. Okay, communication between Azure resources, something which we've already discussed. So now I can just read out the slide, because when I was drawing the diagram, I already explained this concept in brief. So to establish secure communication between resources, there are two options. First, you can have a virtual network which can connect multiple virtual machines together, such as a lot. I'm not going into the names just to avoid confusion. The second one is using service endpoints that you can use to connect to Azure resources, such as SQL databases, storage accounts, by linking multiple resources to virtual networks. These options improve security and provide optimal routing between resources. Now, out of this definition for the exam, obviously you need to go through this definition. Let me highlight what is important out of this. So the first thing is you can have virtual networks. Once you divide your resources, let's say in VN1 and VN2, all the resources within VN1 can communicate to each other, because you have a public IP, you have a private IP addressing model. So everything can talk to everything. And that's what we are talking about here. So first, virtual network can connect virtual machines and other resources such as Kubernetes service, app service environment for Power Apps. You could take simpler examples like database and maybe blob service that I have taken, and they can connect to each other. So either we can do this, network one, network two, everything in network one connects to each other, everything in network two connects to each other. Second option that we have is using service endpoints. When you're using service endpoints, you can connect to Azure resources. So this is basically an Azure to Azure connection. So even if a resource is within another virtual network, if the resource uses service endpoints, you can connect to it. For example, let's say you're using Azure SQL database, or you're using storage. This should, something that could be shared. What you could be doing is, if you put them in multiple different networks, because of, let's say, let me give you a very good example with this by moving back to the draw.io. Let's say we have a use case where this database is we need to migrate data from database one to database two, because this is our old website, this is our new website. So one way of doing it would be, we take the data out, we make it internet accessible, we take it out of Azure, we make this internet accessible, and we put it over here, which is obviously not secure. So it's more secure to stay within the Azure network. So what you could do is, when you are implementing Azure networking, if it's done the right way, you could establish a tunnel. You could create a connection between different virtual networks as well. And this is done via, for example, if you want to connect this database, or maybe, let's say you create another machine for migration, which I'll create in a while. You can connect it to this database. Let's say we create another machine, we'll call it virtual machine 4. The job of this virtual machine is DB migration. In simple words, it is doing nothing, but it is just migrating from one place to the other. And I'll make it a no public IP. I'll explain why. We'll be accessing this machine via something like a jump server or something. I'll talk more about that. Just give me a few minutes. Let me expand the size so that I can have space to add something new. Okay. Let's say, after working on this for a while, we realize that now is the time that we want to shift our data. We want to shift our data between, our first network to the second network. So we could design our solution in such a way that we create a temporary machine, which is for migration, which is called virtual machine 4. This virtual machine 4 will, because it's in the same subnet, it will have access to this database. Okay, before I draw this, I hope everyone understands this. So we created a new virtual machine. The job of this machine is to move data from here to here. And since they are in different networks, we cannot do them directly. So what we did was, when we got virtual machine 4, it has access to database 1. Is this clear to all of you till this point? Give me a thumbs up if it is. Let me pull out the participant list on my left so that I can see if you're all active. Okay. Awesome. Now, this is done because it is done because it has the privilege of being in the same virtual network. But let's say we want to move this data, whatever this is, virtual machine 4 is reading from database 1, we need to move it to database 2. We cannot be doing that if we do not have access to database 2 from database 4. In order to do this, this is where we would be using the concept that I was just talking about. Let me go back to my screen, the other screen, the sharing screen. So for the second, you need to use something called a service endpoint, which allows you to connect to Azure resources such as SQL databases and storage accounts by linking multiple resources to virtual networks. These options improve security and provide optimal routing between resources. So now what is happening is, when we want to move our data from one place to the other, we will use the service endpoint. Service endpoint is for storage. It's something which we use for the storage service as well as for the database service, which will allow you to access the resource even outside the virtual network. So because it's an endpoint, that's what Azure is provisioned for us. And now since we can do that, we'll get the data from here and we'll move it to database 2. Does that make sense to all of you? This, okay, let me mention it so that it becomes more clear. This connection is an endpoint connection. Not all services allow the service endpoint connection, but services such as database, services such as, let's say, your blob service or storage service have this concept of service endpoint connection, which could be used to connect to these services outside your network. Because database, if you look at database conceptually, it is something which you might want to connect to from multiple networks. Even if it is isolated, since it's storing data, there might be cases when you want to analyze the data. There might be cases when you want to read the data. And when you are dealing with that kind of data, you can use the service endpoint connection along with the virtual network. So now these are segmented, but at the same time, they are accessible. So this would be like our jump host. We might be able to access this from the internet or from some other resource internally. And then using this resource, we can read from this database 1 and move data to database 2. And in the process, we could also do some ETL operations that we have to, but again, not the scope of this workshop. How these connections are set up, that is, can you please elaborate by unmuting so that I could answer your question? Someone asked me a question in the chat. The question is, could you elaborate on how these connections are set up? Just want to know what exactly are you looking forward for? Do you want me to show you the practical? If that's the case, I'm sorry, not for this workshop, not possible. Way too deep, way too beyond the content. But oh, so through ports and networks. Ports, okay, port is like, for example, if this is MySQL, this is going to be 3306, right? So it might have the same port. The connection is done that your virtual machine is connected to this machine because it lies in the same network. Since it lies in the same network, all the devices have a private address. So you can use the private address along with the username, password, and the database name to establish the connection. You can read data from here. Now, when you want to move it, you do not have a private address the same. You do not have a private address between two different networks, right? So this is a 100 series. This might be maybe a 200 series, for example, in IP addressing. And if you still want to establish the connection, you can do that using the concept of service endpoint that allows you to access certain resources, such as a database, such as a storage, such as a storage service outside the virtual network as well. Does that make sense?
Yes, that makes sense. Thanks,
Okay.
Professor.
Awesome. Let's go back. Okay. Used a lot of stuff over here, a lot of drawings. Let's come back. Let's go on to the next concept, that is communication with on-premise resources. This is going to be interesting because this is where we are talking about using something called as hybrid cloud. You guys remember we discussed about hybrid cloud yesterday? I hope everyone remembers what a hybrid cloud is. Anyone who does not? Okay, I'm assuming everyone does, but let me give you a quick recap. So let's say if you're using a public cloud such as Azure, so I'm just going to name it AZ, and at the same time, you also have a private cloud. Let's say we were talking about OpenStack yesterday. So someone's using OpenStack and which is on-premise, okay? Let's say if you want to communicate, some resources are in your OpenStack, some resources might be your on-premise, some might be on, a private cloud. If you want to communicate with them, if you want to establish a communication with them, could be multi-cloud, could be hybrid cloud, or could be on-premise, this slide is going to apply. It says communication with on-premise resources. So Azure Virtual Networks allow you to link resources together in both your on-premise and Azure environments. You can achieve this connectivity through point-to-site VPN. Now, please understand what this is. There is definitely going to be a question on this. Please listen to me very, very carefully. I'm going to explain. If you see in the exam, they're asking a question about point-to-site VPN. It's called PTS VPN. This point-to-site VPN connection allows you to connect your Azure with your resources on some other location. Does that make sense to all of you? Give me a thumbs up if it does. Very straightforward. As the name says, point to site. That means point is Azure, site is your own on-premise resource. If you want to connect the two, you will be using a point to site virtual private network, point to site VPN. And whenever you hear the term point to site VPN, it is used to communicate between on-premise and Azure resources. Now, those on-premise might be on a private cloud, they might be on some other cloud, you might be using multi-cloud, but you would have to enable point to site VPN if you want to access them. Site to site virtual private network in Azure. Okay. You could also be using site-to-site virtual private networks. You could also be using Azure Express Route. Now, these are all three different, services that are used for connection. For example, point-to-site is your on-premise to Azure. Site-to-site would mean something like, two different accounts in Azure if you want the connection between them. And Express Route is another service that we'll talk about in a while. So once we come to that, I'll talk more about it. So the former two options use encrypted VPN connections over the internet, while ExpressRoute provides a dedicated private connectivity to Azure for higher bandwidth and security. Okay, it got answered here itself. So let me briefly explain what this is. Let's say we have certain resources in this account, and this is our first AZ account, okay? And then the other resources are on-premise. On-premise means, let's say, in your office, an old machine, or some legacy system, or maybe you've kept some critical data on-premise. If you need to access, if one of your resource needs to access the data stored on your on-premise location, you will be using a PTS VPN, that's point to site. So point is basically Azure. So point to site is using a VPN to connect from one resource on Azure to something stored on-premise. Everyone understands this? Give me a thumbs up. We'll go step by step. On-premise, okay, Munib, I think you forgot the content that we discussed yesterday. So on-premise is your own thing, that is off cloud. For example, when we started talking about cloud computing yesterday, you can either be storing data on cloud, or you could be storing, you could be having virtual machines locally that are connected to the internet, which are not on cloud. So you've already bought them, you've connected to them. That is on-premise. So when you connect from one resource to another resource, so when a connection is happening between Azure to your on-premise, it is point to site. Okay. Site to site is when you have two different AZ accounts. So when you have two different AZ accounts, let's say, one for one corporation, second corporation uses the services of the first one, then you are using a site-to-site VPN, because that is Azure to Azure, right? From one, like for example, my account to your account. Or let's say if you are an analytics company and I am a production company and I'm using your services and I want to connect to your account's instance, not your API, something not accessible over the internet, I could be using a site-to-site virtual private network. And then the third thing is, if I'm a huge company, let's say I am a Fortune 500 company, I have tons of money to pay to Azure. I can tell Azure, please create an express route service for me. So that is like a dedicated line that Azure has created for you, a dedicated connection that Azure has created for you, which only you can access, which is obviously very high bandwidth, very low latency, but very, very, very expensive at the same time. VPN is just a virtual private network. It is not something very expensive. They just create it for you. If you use an Azure Express route, you're paying tons of money because it is a real dedicated network connection that you are making between an Azure region and your on-premise location. Does that make sense to all of you? If it does, give me a thumbs up. 4, 6, 7, not everyone's active. Getting confused? I think it's pretty straightforward. Should not be super difficult to understand.
I'm sorry, I just have a question.
Yep, go ahead.
What is the difference in terms of security between VPN and this like physical connection?
What is better in terms of security?
No. What's the difference in terms of security?
In terms of security now, this is like, if we look at point to site VPN, this is basically a category. This is not a product that we're talking about. Depending upon the implementation, you could be setting up your own tunnel. You could be setting up your own security. You could be using, TLS. You could be adding additional layer. You could be using some, encryption techniques so that the traffic, when it is moving, because there's no security or traffic up, data at rest, because that is taken care by your resource. But when data is in motion, VPN, depending upon how you implement your VPN or depending upon which product you are using, you will be looking at what security it is implementing. Whereas for Express Route, since it's an Azure service, it is considered one of the most secure ones because there's no third party involved in between. It is directly a connection between Azure and your on-premise place. Make sense?
Yes, thank you.
Okay. Is Azure Express Route similar to MPLS? Express Route, please again. Okay. Guys, just 2 minutes. We'll come to that. We will be coming to the concept of Express Route in a bit. Okay. Let me first explain these concepts and then I'll come to the questions that you have, because we received some feedback in the afternoon that some people are feeling that the questions are too many and the content is lagging. I'm just going to come to everything. Just give me 2 to 3 minutes. Let me first explain the concept. Many of your questions will be answered on the way itself. If they are not, I'll be more than happy to answer all your questions. Okay, just bear with me for a few moments and you'll see that they're being answered. Okay, so when we talk about route network traffic, Azure offers options for controlling routing between virtual networks and on-premise networks. Route tables and border gateway protocols can be used to define custom routing rules and propagate on-premise BGP routes to Azure virtual networks. So this is about how traffic can be, routed from one place to the other. You can be, when you use Azure virtual networks, you can use route network traffic to, decide what will be the routing tables, what protocol is going to be used, how would you be routing is basically what is the path that your data is going to take in order to reach from one place to the other. So that comes under this. This is not, again, super important for the exam. So not going in details of this. This is kind of important. So let's talk about this first. That is filter network traffic. So we have just used a network security group. When I was doing the practical, I was using a NSG, and that's why I'm saying questions will be answered in a bit in the further slides. So I just do not want to pause them right now. Just understand, and then I'll come back to the services. So when we talk about network security groups, Azure resources that contain what can go in and what can go out you define rules to block the traffic or allow the traffic depending upon address, port, and protocol. This is, you can think of this of something like a firewall. This firewall will allow certain traffic and will deny certain traffic. For example, if I am creating a VM that is a Windows VM, I need to configure a NSG, that is a network security group, where I will define that, okay, I want to allow RDP, that is a protocol used to connect to Windows. So that is going to be on port 3389. And then I'll say, okay, I also want to allow HTTP, which is going to be on port 80. I hope you guys know this. So HTTP, the web port is port 80. RDP runs on port 3389. What you need to know from exam standpoint of view is, whenever you create a resource and you by default do not want it to be, everything to be accessed over the internet, you want to have additional level of security, you use the concept of network security group. Network security group makes sure that you are only allowing certain type of traffic to come in and go out. So this is how you can do the network filtering. So any data that is coming in and going out, using the concept of network security group, you can decide what kind of data will be allowed and what will not be allowed. For example, on the internet, you might be accessing HTTP on port 80, HTTPS on 443, SQL connections on port 3306, RDP traffic on 3389. Again, this is not, you do not need to learn all the ports. I'm telling you a very broad level overview that when you have a VM, you can use a network security group to decide what kind of traffic will be allowed and what kind of traffic will be denied, the role of a firewall. So any questions on this? First, I'll answer questions on this, and then I'll go back for the questions you had on route and other stuff. If you understand this, give me a thumbs up. Not impressed with just 15 to 20 people being active. Let me explain it one more time, and then I'll ask the same question again. When we talk about filters, we are basically defining what traffic can come in and go out of a network. We are adding an additional level of security. In order to do that, we use something like a network security group, which makes sure that only certain type of traffic is allowed to come in or go out. That is like if someone is viewing a website, they'll be doing it via HTTP or HTTPS. So you allow, okay, if I'm hosting a website, please allow these ports. If you're hosting a database, there'll be a separate, let's say port, you might allow that. So setting your own instructions, what is allowed, what is not allowed, is the job of network security group. It is a firewall, which is like, defining what can come in and what can go out. Ingress or inbound is data that comes in. Outbound or outgress is the data that goes out of that specific machine. Next concept that we need to learn over here is a network virtual appliance. That's a NVA. Now, these are specialized virtual machines that carry out network functions such as running a firewall or performing WAN operations. Let me give you an example. How many of you have encountered when you're connected on the Concordia Wi-Fi that all websites cannot be opened? If you try to open a website that is blocked, you might have seen this message saying, right, that Fortinet or any firewall, web application firewall or any network firewall is not allowing you to access a website. So when you have those kind of controls, you could be adding physical appliances. That is again an option in Azure, which will stop you, like network virtual appliances, which are more, I would say, specialized. Just a sec. Yeah. So network virtual appliances, which are more specialized in deciding what sort of traffic should come in and what sort of traffic should go out. So if I do the comparison between the both, okay, so if I do the comparison between the both, the first one is network security group, where wherever you create a resource, you're just telling which port is allowed and which is not allowed. When you're using a network virtual appliance, it is way more specialized. By specialized, I mean that a firewall is much more than a security group. It is not just restricted to the IP address, port, and protocol. It can be running dedicated custom rules. It is just a more enhanced and a more advanced version of the same. Does this make sense to all of you? If it does, give me a thumbs up. I want all of you to be active, please. Okay.
Can you just repeat it by any chance?
Yeah, sure. So
The network virtual appliance.
So network virtual appliance is specialized. It is way more dedicated. It is an enhanced version of an NSG. It is a dedicated machine that is making sure what sort of traffic is coming in and what sort of traffic is going out. And you do this for your, uh, for example, to add additional security, you can have more rules. In network security group, the only rules you can have is allow this port, deny this port, allow this IP, deny this IP. If you look at your network virtual appliance, it is more configurable. You can be working, you can be having a higher level of customization and a higher level of security configurations that you could be setting in a network virtual appliance. Got it? Pranay?
Yeah.
Okay. So, Bhargav, how can we set which website to allow? So, Bhargav, that is basically, I was just giving you an example of what, a network firewall or what a prevention system at a network level can do. How you do it, again, is not a part of the exam because there are specialized software. We are talking about the categories here. You could be using multiple solutions to perform the same task, and hence it is not limited to just one product. The way of doing it in every product is going to be slightly different. Second, is NVA part of IAS service? So network virtual appliance, yes, you could, since you can do a lot of configuration, I would say it will be a part of IAS or maybe even PAS because you are getting a platform. So I'll have to look into this and get back to you. I'm not very sure, but if I have to categorize NVA somewhere between IAS and PAS, because certain services are both depending upon how you can configure them. So I'll come back to that question later after looking into it. Maybe next week I'll answer that. I'll mark a note on that. And Alokik has asked a question. Can you please explain with example of advanced security rule in NVA? Advanced security rule in NVA again depends on product to product. For example, let's say some firewalls can have machine learning enabled and they can detect when a pattern of traffic is malicious. So if you're getting X and X amount of requests in a particular amount of time, that might be malicious. So that is a kind of a specialized rule that you might set with an NVA, but might not be able to do that with an NSG. And this is again an example, again, way beyond the content, because as I'm saying, by the end of this series, we would have already discussed about more than 50 services by names, right? So using them or knowing about all of them is not what is required. Repeating the same thing again and again, this is a fundamental certification. You're required to know what is happening at a very broad scale. Now, let me come back to the question that someone was asking me, what these services are. Okay. So when we talk about services such as Express route, oh, okay, no, I don't think this was the one. PGP. I think, yeah, the question was an Express route itself. So someone was asking me about what are the options about point to site, site to site, and about Express route. So Express route is an Azure offering for huge organizations that allow them to connect directly to Azure data centers using a private connection. It is not an internet connection. It is a dedicated connection between an Azure location to your office location. Does that answer the question? Whoever asked me about Express route, not remember the name, I'm sorry, but is it clear? Okay, so I see a thumbs up. I think it's all good. Okay. Next slide. So this is connecting virtual networks. So virtual networks pairing allows for two virtual networks to be connected directly to each other on Microsoft Backbone network, enabling private communication between resources in each network. So user-defined routes can be used to control routing tables between subnets with a virtual network or between networks for greater control over network traffic flow. Let me give you an example of this. For example, I work in XYZ organization, and we want a secure way of communication between XYZ communication and the Azure resources that we have. So we can be using we can be connecting our virtual networks. So there is a possibility that the company's virtual network is connected directly to the Microsoft backbone, which allows us for a very safe communication between Azure and our company resources, so that we do not have to do that openly over the internet. We could be doing that over a virtual tunnel, so that the probability of traffic being intercepted, or the probability of something going wrong, or people being able to read the traffic, goes significantly low. Again, I do not think that is I think that's quite straightforward, but still, if you guys have questions, let me know, because honestly we have quite a few things to cover. My target for today would be as close as we can get to 100 slides, because we have about 150. And I know I'm saying this redundantly, but no one should be having any unrealistic expectations. So in 3 days, we are targeting to learn about the certification. So if the certification does not talk about a topic in detail, I would now refrain from going in detail on that specific topic, because otherwise we'll just lose the course, and we might not be able to cover everything that is required. So I had planned these tasks, but I won't go into them right now, because again, we're taking more on the questions. We can discuss them a little later if we have some time. Yeah. So Soham, I'll definitely discuss on the topics. Honestly, forget the practicals, read everything in theory. The certification wants you to know about everything at a very broad scale. They're not going to ask you to perform any practical. And hence I'm skipping the task, because we have given way more time to the questions than, and then task. The problem is, since all of us do not have the same account, for me, I was running this in the break, and my subscription is giving me some issues, because again, I'm a pass out of Concordia, maybe because of that. So I'll give it some time to rest. But if someone still needs to talk about these tasks, we can be discussing them in the doubt session. But I'll just skip this for now, because there is so much that we need to talk about. Coming to Azure Virtual Private Networks, the first thing is VPN gateways. So Azure VPN Gateway connects on-premise data centers and individual devices to virtual networks through site-to-site, point-to-site, and network-to-network connections. VPN types include policy-based, route-based, with route-based being the preferred method for on-premise devices and multi-site connections. Now, this is quite straightforward. This is what you now, if you want me to tell you what you need to know from the certification standpoint of view, all you need to know is, if you use the Azure VPN Gateway service, you are looking at on-premise data centers and individual devices that are connected to each other, either site to site, either point to site, either network to network. Okay, so pretty straightforward. Site to site is one Azure account to the other Azure account. Point to site is your home network to your Azure account. By your home network, I mean, your on-premise network. Now, let me give you an example of an interesting use case. Let's say this is one of those devices, okay? This is obviously a hard disk, but assume this is a compute resource. And this has the capability to produce some very critical data. For example, it's connected to sensors, and it's getting me information about the weather or the temperature, right? In this particular location where I'm located. And I want this to be connected to my Azure. I could be using a point-to-site VPN if I want that level of security, so that this device could directly connect via private connection to my Azure resources. And let's say if I had 10 of them, 15 of them, they could all be talking to each other within one same network. And we could be establishing a network to network connection, so that our devices on our own network can also be connected to the devices on the Azure network. Does that make sense? The concept of VPN is when you want a set of devices in one network to be connected to a set of devices in the other network. For example, something running in Azure to something running in my home or something running on premise in a data center. If we want to establish that connection, we are looking at PTS connections. Does that make sense to all of you? Then we have side to side, one side to the other side, and then we have network to network. So if we have some big networks, and this is what comes for multi-cloud. So all you need to know is that these are the three, exam standpoint of view, obviously you cannot always remember the entire thing. Just remember that there are three types of networks that are covered by Azure VPN: side to side, point to side, and network to side. And the type of VPN that we choose is going to be the route based. So what is the preference of the VPN? Route based. So if you are making exam notes for preparing for the exam, just make a point. Azure VPN gateway has offerings of side to side, point to side, network to side, and route based is the preference of the connection type. Does that make sense? Because they do not expect you to do this in reality. Doing it in reality is just next to impossible within the time we have, because it's a very, very long process setting up a VPN. But in simple words, this is what you're expected to know. Yes, Bhargav, go ahead.
Yes, sir. So what is the meaning of route based? I can't understand it properly.
Honestly, I mean, that's the thing about this certification. This is beyond you can just think of them that VPN has two categories of products. The first category of products are using something called as policy based, something that are using route based. Now, what they are is something which is beyond the scope. So we'll take this question. If you have this question, ask me later on and I'll answer it. But right now, I do not want to confuse everyone. So all you need to know is these are two different products. The one that is preferred is the route base. Make sense?
Okay, perfect. Yeah.
Because this is specification of a service. This is not even a service. It's specification of a type of service. That's why this classification is not required for the exam. And honestly, the content that they have is bulk, but not in depth.
Okay, no problem.
Okay, so I'll answer
Thank
this
you.
later on for sure. You're most welcome. Okay. So, well, I think your answer is over here. I was planning to just go through the slide real quick, but I'll explain it a little. So when we talk about policy-based VPN gateways, what happens over here is we specify the IP address of packets that should be encrypted through each tunnel. This type of device evaluates every data packet against those set of IP addresses to choose the tunnel where the packet is going to be sent through. Now, how a VPN works in simple terms is, let's say this is the source, this is the destination. A secure tunnel is created between the source and the destination, and then the packet is routed in this location. Okay. So when we talk about a policy-based VPN gateway, we specify statically the IP address of the packets that should be encrypted through each tunnel. So we are telling that what is the IP address that needs to be, encrypted through the tunnel. And this type of device evaluates every packet against those set of IP addresses to choose the tunnel where the packet is going to be sent. So basically, this is too advanced in networking. Honestly, this slide, if you understand this by skimming it, it's fine. Even if you do not understand, you can skip it. It is too much in detail. I added this so that, if someone who's aware about what the differences are, if someone has worked with VPNs, this can be helpful for you. If not, it is way too much to explain it, to everyone, because again, this is like more of like an additional information. But in simple terms, you have a source address. Your packet has a source address. Your packet has a destination address. When you're using a policy-based VPN, you are encrypting that, and then you are sending it from the source to the destination. In the second one, in route-based gateways, IPsec tunnels are modeled as a network interface or virtual network. and then you are routing it from one place to the other. I would not go on the slide for now. I'll see if I have some time in the end. I'll take this, but I will take the slide to be optional. Reason being, it is way too much technical information. So for someone who knows about networking, you can read through it later. Get back to me. I'll be discussing it later. But if not, not important from the exam standpoint of view. So Bhargav, I'll just come to this later. Okay. Now, coming on to the next concept, which is super important from cloud standpoint of view, and that is high availability. So when we talk about high availability, we do not want downtime. If you guys, how many of you have heard about a DOS attack? How many of you know what DOS is? Denial of service. Raise your hands. Just want to get a quick idea. Quite a few. Okay. Thank you. You can all lower your hands. I've got an estimate about 30–40% of you have heard about what a DOS attack is. For the others, let me give you a very quick brief. When someone is trying to access your website and your website is not available on the internet, that is an example of a denial of service attack. Okay. If someone is trying to connect to your website and then not able to connect to your website, or not able to connect to your database, or not able to connect to your resource, that is what is called as denial of service attack. High availability is when your website is prone to attacks like denial of service. Now, denial of service can happen in two scenarios. One, that, genuinely there are so many requests, which is called as, flash crowd. For example, let's say there's a sale on my website. Everyone wants to visit my website, so my website hangs. That's normal if I'm not prepared for it. Secondly, if this, if intentionally someone wants to harm my website, they send a lot of fake traffic. They use a lot of, a lot of methods to perform a DOS attack or maybe a DDoS attack. They do it distributedly and they attack the machine. So when people attack your machine, or when people send you unwanted traffic, or maybe even wanted traffic, which is beyond the capacity of your system to handle, your availability time is going to go low. Your availability will be low, and hence that is not required. When we are using Azure services, or when we are using cloud services, high availability is one of the most important requirements, because if our website or if our container, or let's say if our database is not available to connect or not available to be used by someone, what is the use of that appliance being there at the first place? Does that make sense to all of you? So high availability is always desired in the cloud with anything and everything that we use. So when we talk about active standby, just give me a sec. When we use active standby, VPN gateways are deployed as two instances in an active standby configuration. So the configuration instance automatically assumes the responsibility for connections when active instance is disrupted. When we talk about only active, not about active standby, like active, with support for the BGP, that was the protocol we were talking about previously. When we use the BGP routing protocol, VPN gateways can be deployed in an active configuration with unique public IP addresses assigned to each instance. And then we could have an express route failover. That is a VPN gateway that can be configured as a failover path for express route connection to ensure a connection to a virtual network in case of an outage. And now we're talking about high availability in terms of VPNs. So when we look at VPNs, these are the types that we have. We have active standby, we have active, we have express route failover, and then we have zero redundant gateways. Let me start by explaining active express route, because this is one of the easiest ones. So when we configure this VPN, it is like a connection between Azure, so this is AZ, an Azure data center, and the connection between our location. So for example, this is our on-premise location and office in Montreal. Okay. So when we are establishing a connection between this place to this place, let's say if we have used express route as a connection, there is a probability that express route might fail, right? Because it is a dedicated connection. Though the probability is low, it's a private connection, it is secure, but nothing is 100%. It's not guaranteed to have 100% uptime. Hence, if this fails over, you need a fallback mechanism. A fallback mechanism or a failover mechanism is you have, along with express route, you also configure a VPN, that's a virtual private network. So you have a VPN, that is a virtual private network that you have configured, which is the express route failover, which will only kick in effect if the express route connection is disrupted. Does that make sense? So for high availability, what we are doing is we are having active standby, we're having active, we're having express route failover, and we are also having zero redundant gateways. So express route, I hope this is clear to all of you. Moving to zone redundant, in regions that support availability zones, VPN gateways can be deployed in a zone redundant configuration to bring resiliency, scalability, and high availability to virtual network gateways. So this is more of like, if you are using a region that supports zones, you can have a redundant VPN. So, one in zone 1, one in zone 2 within the same region. So if one goes down, the second will be there. Active standby. So I think express route and zone is quite easy to understand. Let me come back to active standby and active. In active standby, VPN gateways are deployed as two instances in an active standby configuration, which means one of them is active, one of them is on standby. Standby means it's ready to be used, but it's not being used. If this goes down, you can automatically go to the second one. In active, you have both of them enabled. So if one goes down, the other one will be automatically there to serve it. So maybe let's say you're using something like, if you're using active configuration, you might be using something like, let's say, round robin. So some requests might go to this, some might go to this. If one goes down, all requests will be going to the one that is remained active. Does this make sense to all of you? Yes, no, maybe. Okay. Now comes Azure Express Route. Okay. So Azure Express Route enables organizations to establish private connections between their on-premise infrastructure and Microsoft cloud services such as Azure, and obviously 365 as well. So two different products, but yeah. If you're using the Express Route service, as I've already explained this previously, if you have an on-premise data center, so on-premise data center, and then you have an Azure account, it is a dedicated private connection established from your location to the Azure cloud location, which is secure, which is safe, which cannot be intercepted by people in the way. Okay, so this is established by using express route circuit, which can be established over an IP VPN network, a point-to-point Ethernet network, a virtual cross connection at a co-location factory. So, there are so many options that you have out here, but one of the most popular ones that is used when you're using express route, or I'll say one of the most secure ones that is used is, using a point-to-point Ethernet network. That means you have a physical wire, you have physical fiber optic cable, which is connected from your own data center to Azure, so that you can store some data in your data center and something on Azure. This is usually done when you have a lot of data you're trying to migrate, or it is done when you have data that you do not want to store on Azure for safety reasons. So let's say if you want to enable encryption at rest and you think your compliance is better to do it on premise, you store the data with you on premise and then only move it to Azure when it is required for processing. Does this make sense to all of you? So guys, I know it is the second day after a very tired Monday to Friday, and on a Sunday afternoon, people have started to lose their energy. It's absolutely fine. It's totally human of us to feel tired by now. And definitely that's why, I can see it in terms of some people dropping, that's normal, that's absolutely fine. That's something which, I anticipated yesterday itself. But now you need to understand that the services that I'm talking about, these are going to be, multiple choice questions in your certification. And today I'll also be talking about how to get the certification vouchers. So please hang up, with me for the next 30-35 minutes. Just stay active, stay alert. I'll be talking about quite a few services that are very important for you. So let me give you a quick, for those of you who have lost your concentration, let me give you a quick recap. Express Route is a service that Azure offers. If you have certain data that, certain amount of data that you want to store on premise, certain resources you want on the cloud, you can create a express route connection between them, which is expensive, which is secure. One of the options to do it is using a point-to-point Ethernet network, that is using a physical network between Azure and your on-premise data center. This is making it very, very secure, but at the same time, this is going to be expensive as well. Now, if you look at this, express route are reliable, faster, and secure than public internet. This is preferred only for organizations with high bandwidth, low latency, and mission critical workloads. For example, if you are a huge company which has a huge amount of data on premise, and only if the benefits overpower the cost that you are paying, people would want to go with the express route service. So if in the certification they ask you what is express route, or where do you use express route, so it is a service used to connect on premise to Azure. You could do that via a secure tunneled VPN connection. You could be doing that via a point-to-point Ethernet cable, or you could be doing that via a cross connection at a co-location facility. So that's quite straightforward. It's like connecting Ethernet cable directly to a laptop faster network. Yeah. So I think, Pranay, that's a very good way to look at it, because you're avoiding the huddles. So it's going to be, high bandwidth, low latency. It's going to be expensive. Ethernet cables are not expensive, but here it's like plugging in a cable from your data center to plugging in a cable in Azure, though it's not just one, but yeah. Example. So if you are plugging in cables in both the places, the connection time is faster, it is reliable, it is secure, and it is very expensive compared to the public internet, obviously. Bhargav, go ahead.
Yes, so I would doubt like the point-to-point Ethernet network and express route both are different things, right?
No. Express route is done using one of them. So if you are using express route, you could either be using a VPN to do that. You could either be using a point-to-point Ethernet network to do that. So this is how express route is implemented. This is the implementation.
Okay, perfect. Got it. Thank you.
Most welcome. Okay, next we have Azure Domain Name Service. So Azure DNS is a domain name service hosting service that allows for name resolution using Azure Infra, providing centralized management for DNS records with consistent credentials, tools, and billing, blah, blah, blah. In simple words, Azure DNS, let me take you to my draw.io. Let's make things more interesting, because obviously drawings are much interesting. So if I deploy this virtual machine, the IP address is 10.23.43.21. Tomorrow, if I have to share this IP address with Gautam, Bhargav, Pranay, Saurabh, or anyone whose name I see on the screen, do you think you'll remember the IP address? No. Humans are not very good with remembering 0 to 255 set of 4 numbers, right? That's not the best way to give a name to a website. And that's why we have something called as the DNS. So the job of the DNS is to convert your website name into an IP address. So let's say if you have this resource and you want the world to be able to access your resource, rather than the world going on the internet and typing 10.23.43.21, they could be using the Azure DNS service, which let me put it over here. And they could just enter ecsga.ca. And again, this is not the real website. I'm just using hypothetical names. So let's say if we have an Azure DNS service, Azure DNS service will be like, okay, I know what to do. I'm going to keep a record that ecsga.ca is this IP address. So tomorrow, if someone comes to us and says that I want to go to ecsga, it is going to route us to 10.23.43.21. So essentially what's going to happen is we'll be like, hey, Azure DNS, I want to open ecsga.ca. And then Azure DNS will be like, okay, if you want to open that, I am the record keeper. So according to my records, you need to go to 10.23.43.21. So this is like buying your domain names. So when you buy, if you might have seen people go and buy domain names on GoDaddy or other services, similarly, you could do that on Azure DNS as well. Obviously, it's not free, it is paid. If you want to register a name, you have to go through the process of, beyond the free account. But yes, once you register it, you could be using it, you could be mapping it to any of your resources. Going back to the definition, DNS, Azure DNS is a DNS hosting service that allows you to that allows for name resolution using Azure Infra, providing centralized management for DNS records with consistent credentials, tools, and billing as other Azure services. So basically, rather than buying a name on GoDaddy or buying a name on some other Big Rock or some other website, you could directly buy your domain name from the Azure DNS service. Does that make sense? Give me a thumbs up if it does. All of you, it's pretty straightforward. So if in the exam they ask you what is Azure DNS, Azure DNS is a service used to manage your domain name service infrastructure. What is a domain name service infrastructure? It is like, ecsga.ca, google.com, facebook.com, concordia.ca, and the list goes on and on and on. Okay, moving on to Azure storage. This comes the fun part. Obviously, no time for practical, but yeah, let's get through this. It's already 2:30, so I'm planning that. Which slide are we on right now? Okay, so we are already on slide 80. That's a good thing. About 20 more to cover. So great, we have 30 minutes and we have about 20 slides. Let's be optimistic. Let's cover as much as we can. And then don't worry, I'm going to answer a lot of questions that you might have and a lot of additional information as well, which we'll be discussing off the record. So about some sample questions as well. So just hang in there for some more time. Coming to the Azure storage account. So let's say when you're talking about Azure storage, you'll be dealing with something called as a storage account. So when we talk about an Azure storage account, it is a container for Azure service data that can be accessed globally. Now, remember yesterday I was talking about services that are global and services that are on region. So when you go for the Azure storage account, you are going for a global service, which will allow you to create your data sources within different regions. You could have region pair replication, you could have availability zone replication, you could decide all of that, but the portal that you will be using your storage account. Okay, so as the definition says, the storage account is the container for storage data that can be accessed globally. By access globally, I mean, let me not bore you with the slides. All of you can pay attention to me now. And just raise your hand if you just give me a thumbs up or raise your hand, whatever. So for the next question that I'll ask you, how many of you have ever worked with HTML, CSS, or just creating a hello world basic HTML site, a static website? How many of you have created it ever or know how to do it? Just give me a thumbs up, raise your hand, anything will be fine. Quite a few. That's nice. Okay, thank you so much, everyone. Just you can lower your hands. Okay, now I'm going to give you a very good example. Now, the major difference between a static website and a dynamic website is, in a dynamic website, you need to have backend and you need to have a programming language, right? You need to have PHP or Python or Node.js or Java or anything else, right? Going in the background, Ruby on Rails, Go. There are so many options these days. For a front-end technology, you're just going to have an HTML, you're going to have CSS, you might have JavaScript, you might have some images, which we call assets, you might have some fonts, you might have some pictures, image picture, the same thing, you might have some GIFs, you might have some videos, some music, blah, blah, blah. Static data that is working on your browser, right? You do not need an active server to host a static website. So what happens in this case is when you are creating a static website or when you are creating a static resource, To save money, please mark my words. It's very, very important. So you might have seen some people with those portfolio websites that they build, right? Some people do it on Bootstrap, some people do it from scratch, some mobile friendly websites. If you have a website of that sort, which is not frequently accessed, you do not want to pay for an active server full-fledged. What you could be doing is you could be having a storage account, you could have a static storage service where you can just upload your data. So it's like a placeholder for the data, and then you could expose that data to the internet. That would make hosting available for you without the need to spend money on having a very fully active server. Does that make sense? So it's like a drive, it's like a folder where you're uploading data, and that folder can be accessed from anywhere on the internet. And that's a very good usage of, the storage service. People use some blob services to upload the data, which people do not need to access very frequently. And then if you have used that once, you can just share it with the others, and the URL with the others, and the others will be able to see your website hosted on Azure without the need to run a full-fledged virtual machine. Does that make sense? Because when you are working on PHP, you're working on Python, when you're working on a backend language, you need to have a server that is running in the background. That's not the case with your storage account. With your storage account, it is pretty straightforward. It is not so difficult. It is just that you upload it and that data can be accessed by anyone in the world. And that's why we use storage accounts. Coming back to the definition. Okay. So when we talk about Azure Storage Account, Azure Storage Account is a container for storage data that can be accessed globally. So let's say if you upload an index.html file along with the JavaScript file, along with some pictures within one folder, and using the storage account capability, that could be a static website that could be accessed by anyone in the world. When creating a storage account, the storage account type is chosen, which determines the storage service and redundancy options available. The choice of storage account types impacts the use case and the level of availability, durability, and scalability of the stored data. We will be talking more about this in the further slides, but let me give you a very broad overview. You can decide if you want 1 copy of your data. You can decide you want 2 copies of your data, 3 copies of your data, or 10 copies of your data. You can also define if you want it in one region, if you want it in multiple availability zones. You could also define if you want to access the data frequently or infrequently. The price varies. I'll be talking about all of this. It's all there in the future slides, but just to give you a very, very, very broad level overview, a storage account is basically a container that you create on Azure, which allows you to access storage services that you would be using. And one of the examples and one of the best use case that the world is using these days is using blob accounts, blob storage to host static files. And then those static files are making API calls to the backend using function as a service. And that's how you're going to a serverless model. Without spending a lot of money, with minimum investment, you are getting maximum output. Ankit, you can ask me a question.
Like the way I understand is, so Azure Storage Account is something like a feature-rich or a complicated version of Microsoft OneDrive, something like that, like a cloud-based storage.
No. Not exactly. So
Okay.
a storage account is basically when you create a storage account, right? You go further, you select, you give the options, and it's going to create a container for you. So it's basically a container for multiple services. So you have a blob service, you access that by the storage account. You have an archival service, you access that by the storage account. Things of that sort. Make sense?
Yeah. Okay. Thank you.
Most welcome. Okay. Now, storage redundancy. So what you can do is you can have locally redundant storage, you can have geo-redundant storage, you can have read access geo-redundant storage, you have zone redundant storage, you have geo-redundant storage with zones, and read access geo zone redundant storage. Quite complicated. Don't worry, this is all coming up in the slides as we go further. So the first thing is redundancy in the primary region. So Azure Storage always replicates data 3 times in the primary region. Please listen to this very carefully. I know I just skipped the last slide because that was just the names which we are going to be talking about in detail. Okay, please focus on my screen. Won't take more than the next 20 minutes. I might not go all the way to slide 100. I might just stop at 90, leave something for next week as well. But please pay your utmost attention right now. So redundancy in the primary region. Every time you're using Azure storage and you're uploading a data, your data is being replicated 3 times in the primary region, and it gives you the option that you could be doing it locally, or you could be doing it zone. Okay, you could be doing it at a zonal level. So locally is you're doing it within one availability zone. Let's say this is one availability zone. This is another availability zone. They're part of one region. Let's say we have a third availability zone as well, AZ1, AZ2, AZ3, and then you are in one region. Let's say maybe in Canada Central, or let's say maybe in US East, whichever region we are in. Within this region, Azure Storage always replicates your data 3 times in the primary region and offers 2 options for replication. So within one region, it is going to replicate your data 3 times. So either you can do it locally, or you can do it zone redundant. So either it could be in, in this zone, this zone, this zone, or it could be done just within one zone. So that is an option that you get to store data. Basically, it's storing your data multiple times so that you do not lose the data. That's the primary, underlying reason. Technically, at the end of the day, it is hardware. For example, if you give me, maybe $10 a month to store your data on this drive, I might do it for you. But who knows, what if tomorrow this crashes? I cannot be 100% sure, right? Because it is technology. No one knows if it will last a year. No one knows if it will last 10 years. Even if I have warranty, is there any guarantee that I'll get back the data? No. The warranty is for the product, not for the data, right? That's why the only way to make sure that you do not have data loss is to store it multiple times. Either I can store the same data 3 times in one zone, or I can have 2 different zones and store the data in 2 or 3 different locations, so that if this goes down, this is there. If this goes down, the third one's there. Does that make sense to all of you? Okay, Alokik, so first things first, basically you are not having 2 copies, you're having 3 copies. As per the definition, again, it's a very important exam question. Is your storage always replicate the data 3 times? And this does it in the primary region. And in addition to doing it in the primary region, you could also be having a LRS or a ZRS. So if you look at this, this is the local redundancy. And then zone redundant is doing it across 2 different or 3 different zones, depending upon the number of zones available in that region. So as I talked, most regions have 1 to 3 zones, but yeah, that's what it is. So redundancy in the primary region. Okay. Now moving on to locally redundant storage. Locally redundant storage replicates data 3 times without a single, within a single data center in the primary region, offering the lowest cost redundancy option with the least durability compared to other options. LRS protects data against server rack and drive failures, but in the event of a disaster, all replicas will be going at the same time. So let me explain this to you. When we talk about LRS, and in the exam, they will be referring to LRS, ZRS. They might not even write locally redundant storage. So please remember these short forms, just a star mark, okay? So if we talk about locally redundant storage, we are replicating the data 3 times within the same data center. So Azure is like, they are going to store multiple copies of your data. If you store the same copy of the data within one location, let's say within one AZ, within one availability zone, or within one data center, if something goes bad to the first copy, let's say there's a rack failure or a machine failure, right, or a drive failure, one copy will go, the other 2 will still be there, because not all drives will fail at once. But let's say there is a disaster. For example, this entire zone goes down, which usually does not happen, but might happen. In that case, your data would be lost. So you should be doing this for data that is critical, but not so critical that you cannot afford losing it. And because it is storing it in the same place, it is the cheapest option to store data. Does this make sense to all of you? Trust me, this content that you're seeing on your screen is very, very detailed. It has everything covered for the certification. And if you just go through it once, you would remember it. Because again, you might have to make some notes to remember what LRS is. But in simple terms, LRS is storing the same data 3 times within the same data center, within the same availability zone. So if a rack fails or a disk fails, it is still available. But if the entire data center is not there, or the availability zone fails because of a disaster, in that case, your data is not going to be with you. And that's where the last line comes into play. Microsoft recommends using other options like ZRS, GRS, and GZRS to mitigate this risk. But again, they are upselling. Obviously, they want you to go for a higher solution. Gautam, in the same data center, but in different disk, yes, obviously. So they won't put it in the same disk. Otherwise, there's no point of having locally redundant storage. So this is like the most basic, where you're storing data in 3 different locations, but 3 different disks, but within one data center. So if something goes bad to one disk, you are still protected. But if the zone is down, you're not protected. From my experience, I've always stored data in LRS. I have never faced any issues on a common, nothing to be worried about. If it's very, very critical data that you cannot afford, a single millisecond of downtime, you might want to go with the other options you have, but not something very popular use. It's not something which is very popularly used amongst the users that are not having very, very critical data. Nothing to worry about zone going offline. If the zone goes offline, obviously your data is not there for that time. The moment it comes back, your data will be there. Make sense, Gautam? The second and the second level of, let's say, the second level of the second option that you have in terms of storage is zone redundant storage, where you are doing the replica of your data in different availability zones. So what is happening is, if you are in one region, let's say we are in Canada Central, we have one zone, we have second zone, we have third zone. If you guys remember correctly, I told you yesterday, these zones are separated, right? They're not in the same location. So if they're separated from each other, the probability of the power outage in this and the power outage in this is very, very low. So what we are doing is we are making multiple copies of the data within different zones, so that if there's a power outage, or if there's some other sort of outage in terms of network failure or something that goes bad, it will still be there for all of us to access from another zone within the very same region. Does this make sense to all of you? If it does, please give me a thumbs up. I know even you are tired by responding to me saying this again and again, but it's very, very essential for me to make sure that everyone's awake and not getting distracted. Okay. So let me quickly walk you through this. So zone redundant storage replicates data across 3 availability zones in the primary region, offering at least 12 nines of durability for Azure storage data objective over a year. With ZRS, data remains accessible for read and write. Even if a zone becomes unavailable, it is recommended for scenarios that require high availability and for meeting data governance requirement for restricted data replication within a country or region. However, Azure networking updates such as DNS repointing may affect your application if you access data before updates complete. So this is basically telling you that it has a downside as well, because it is having multiple copies of your data across multiple zones. So your data might be effective if, it might be affected if one zone is going down and the other is coming up. So there might be some configuration changes that you might have to do at your application level. Like, for example, sending a request to get data. If the data did come back, send it to another zone. So that is something which you can be doing on your code basis. So again, nothing to worry about. What you need to pick up from this slide is, when you are using LRS, that is local redundant storage, you have 3 copies of the data within the one AZ, right? So one AZ has 3 copies of data. In ZRS, you have 3 AZ holding each copy of the data. So 3 over here, sorry. So when you're talking about ZRS, it is storing your data in 3 different locations. So in one availability zone, in the other availability zone, and in the third availability zone within the same region. And see, we're not doing region redundancy over here. So we're not going outside this region. We are in the very same region. That's why when we talk about ZRS, data is replicated synchronously. That means you update it in one, these are all connected to each other. So they will be updating in all three of them within the primary region, offering at least 12 nines of durability. So 12 nines of durability is okay. So durability for Azure data objects over a year. With ZRS, data remains accessible for read and write operations, even if a zone becomes unavailable. So for example, if there is a fault, let's say I told you all these three zones have their own power supply, their own network outage. If let's say the power goes off in this zone, probability of all of them going down and the region being down, very, very low, very, very, very low. I mean, in my experience, that is not something that you experience frequently. So regions do not just go down like that. Zone might go down, again, very, very rare. But yeah, let's say if it ever goes down, if the zone is inaccessible, the other zone will be able to help it. That's why Azure says if you have some data that is more critical, you could be using zone redundant storage. For example, if you have data like someone's healthcare records, someone's financial records, something that you need to access immediately, you cannot afford downtime, you can go in ZRS. So ZRS is a more secure version. It is reducing your risk by storing it in 3 different physical locations. Does that make sense? Give me a thumbs up if it does before I move on to the next one. Okay. Redundancy in a second region. Now, this is kind of interesting. So please look at this very carefully. Now, what you're doing is zone redundancy in a second region. Azure Storage allows for high durability by copying data to a secondary region for a catastrophic failure protection. So catastrophic, the reason they're using this term is it is not something that you will hear of commonly. A region going down is catastrophic. It is something huge. Until unless something huge happens, you will not hear that entire region is down. But let's say if you have some data which is very, very critical, you cannot afford it to go down. You're trying to beat the odds. In that case, you could be having, you could be using a redundancy in a second region. So two options are geo-redundant storage, that is one, and the second is GZRS, where you have geo-zone redundant storage. So, so basically geo-redundant is having it in one region and then having it in one region. So 3 copies in one zone, 3 copies in one zone. And in the second option, that is geo-zone redundant storage, it is 1, 2, 3 in one region, 1, 2, 3 within the other region. So that is ultimately secure. So geo-redundant, and I'm having slides on this, so I'll be moving to this in the next one. But just to give you an idea, we had local redundant, so 3 copies within one zone. We had the second one we had was zone redundant. The zone redundant was 1 copy in all the different zones. The next one we'll be talking about is GRS, that is geo redundancy storage, where we have 3 copies in one zone of one region, 3 copies in the other zone of other region. And then we have GZRS. So 1 copy, 1 availability zone, 1 region, 2nd copy, 2nd availability zone, 3rd copy, 3rd availability zone, 1st copy of the 2nd region in one zone, 2nd zone, 3rd zone. So 3 zones in one, 3 zones in one. By far the safest is GZRS out of these 4. Does this make sense? Now, this might not seem very logical to a lot of you, but again, the scale at which people use Azure, if someone's spending $10,000 on a machine that critical, they might be having workloads where they cannot afford the risk. And that's why, they might be going for these sort of solutions. So let's talk about GRS. So geo-redundant storage copies data synchronously 3 times within a single location using locally redundant storage, and asynchronously to another location. So if something goes down, the other one will be there to serve you. Okay. And the probability of things like the uptime is 16.9. So 99.999999. That's what we are looking at. We go to GZRS, which is Geo Zone Redundant Storage. Here it becomes even more better because you have, 1, 2, 3, and then you have 1, 2, 3. That's what this documentation says. So Geo Zone Redundant Storage combines redundancy across availability zones with protection from regional outages through geo replication. So data is copied across 3 Azure availability zones in primary region and in 3, using LRS, and then it is also having 3 more copies in the secondary region. So basically, I guess you guys have got the idea, and this is the last slide that I'll be covering today. Remaining we would be covering next week. So, and then obviously quite a few things to discuss in Q&A. So benefits of Azure storage. So Azure storage offers durable, secure, scalable, managed and accessible storage services with redundancy and fine-grained access control. You can use client libraries such as REST API, visual solutions for easy data access and management. Let me add something to this. Azure storage could also be used to run a static website. Okay, by next week, if my account is working all fine, I might just show you a demo for that. Again, not a part of the certification. If you just go through this content, you are more than prepared for the certification. It is very, very detailed. However, just before I finish for the day, I have some links to open for you. And then I'll come to questions as well. So just give me 2 minutes. Okay, just a minute. Okay, so if you look at geo-redundant storage, you can see in geo-redundant, please observe this very carefully. We have 3 copies of the data, copy 1, copy 2, copy 3 within the storage account, within one region. And then we have another region where we are storing it. But this is again one availability zone, one availability zone. If you go for geo-redundant, what is happening is you have it within zone 1, zone 2, zone 3. And you over here, when you go, you have it within, copy 1, copy 2, copy 3 within one zone. So this is using LRS in the secondary region. Does that make sense to all of you? It's not doing a 3 and 3, it's doing a 3 separate zones here, but for the secondary region, it's just doing one zone. So that is the kind of architecture that they follow. Again, not super important for the certification. You should just be knowing that, yes, there are options like locally redundant storage, 3 copies, 1 availability zone. And then you have, you have geo availability zone where you have 2 different geos that you're looking at. And then you have zone, which is dividing into different zones. And then you have geo zone, which is 3 zones, 3 copies, and then another region where you have another copy. So wherever you see the term geo, that means you're talking about 2 regions. Wherever you see the term zone, you're talking about more than 1 availability zone. I think that could be a good way to remember. Again, not to forget that all this is there in, all this is available in the slides that are there with all of you. We have covered all the way up to slide number 89. I won't say that's bad progress. We've got about 60 more to cover on the last day. I'm quite sure we'll be quite fast with that. However, since you have the slides, you want to read the images, you can just click on the links. It will take you to the official documentation where we have taken some images which we could not draw because of copyright issue. So the example that I showed you was from the Microsoft thing. That's why, you can just click over there, open it, view it. Now is the time where I get some time to relax my throat and you guys get to ask me the questions that you have. I'll just stop with the recording. Thank you so much for being so active and all of you being present even on a Sunday afternoon. Really happy to see all of you, going through the first week. Next week, we are going to have the 3rd session. I think 11th is the day when there would be no session. So you will be having a session on 12th with me where we'll finish everything for AZ-900. By next Sunday, because Saturday no session,